Hello, this is not your chem tutor, and in this video, I will teach you how to solve molality. Molality is one of the many expressions of solution concentration. In general chemistry, you will encounter molality in colligative properties, particularly boiling point elevation and freezing point depression. In this video, I included 5 examples so you can practice answering questions about molality. Here are the skills you need to answer problems about molarity. First, you must know how to calculate the molar mass or molecular weight. Second, you must be familiar with mole concept, particularly conversion of mass to moles. And lastly, you must know how to perform dimensional analysis. If you are not familiar with some of these topics, I made separate videos and you can check the link on the description box. Let's proceed right away to the formula. You only need to take note of 2 formulas. The first one is the formula for molality. Molality is equal to moles of solute divided by kilograms of solvent. So the unit for molality is moles per kilogram or mole per kg. Or this is also known as molal, and the symbol is lowercase m. So mole per kg and molal are just equivalent. So when you say 1 molal, that is just equivalent to 1 mole per kg, or 0.750 molal, that is just equivalent to 0.750 mole per kg. The second formula would be the mass of solution. Mass of solution is equal to mass of solvent plus mass of solute. Let's proceed right away to example 1. What is the molality of a solution made by dissolving 0.5 moles of glucose in 1.25 kilograms of water? So in this problem, glucose is the solute and water is the solvent. Remember that the solute is the one being dissolved in the solvent. So to solve for molality, we will be using this formula. Molality is equal to moles of solute. So we are given 0.5 moles of glucose. So 0.500 moles divided by kilogram of solvent. So we have 1.25 kilograms. 0.5 divided by 1.25, this is equal to 0.4. And the unit is mole per kg, or 0.4 molal, lowercase m. This is the answer to the question. Example 2, what is the molality of a solution made by dissolving 1 gram of NaCl in 100 grams of water? So NaCl is the solute and water is the solvent. We will still use this formula to solve for molality. However, we are not given the moles of solute. Instead, we are given the grams or the mass of solute. So we will use dimensional analysis to convert 1 gram of NaCl to moles. So we are given the molar mass of NaCl, 58.44 grams per mole. If in case the molar mass is not indicated in the problem, you need to solve it on your own. So according to the molar mass, 1 mole of NaCl is equivalent to 58.44 grams of NaCl. So grams of NaCl will cancel, Now we have moles of NaCl. And if you solve this in your calculator, 1 times 1 divided by 58.44, this is equal to 0.0171 moles of NaCl. And if you read the problem, we are given 100 grams of water. And the formula for molality needs the kilograms of solvent. So we need to convert 100 grams of water to kilograms of water. So 100 grams of the solvent, we know that 1 kilogram is equivalent to 1,000 grams. So grams will cancel, and this becomes kilograms. So 100 times 1 divided by 1,000, that is equal to 0.100 kilograms. So the kilograms of solvent is 0.100. Now we can use the formula for molality. Molality is equal to moles of NaCl, this one, divided by the kilograms of solvent, and this is equal to 0.171 mole per kg, or 0.171 molal. And this is the answer to the question. Example 3, what is the molality of a 200 gram aqueous solution containing 15 grams of sucrose? Sucrose is our solute and water is our solvent. When you encounter the word aqueous, that means the solvent is water. In our problem, we are not given the moles of solute. Instead, we are given 15 grams. So what we need to do first is to solve for the moles of solute. So we have 15 grams of sucrose. We are given the molar mass, 342.296. So 1 mole of sucrose is equivalent to 342.296 grams of sucrose. So grams of sucrose will cancel, and moles of sucrose is equal to 15 divided by 342.296. And this is equal to 0.0438 moles of sucrose. If you read the problem, it gives us the mass of solution, 200 grams of solution. And according to the formula for molality, we need kilograms of solvent. So we need to find first the mass of solvent using this formula. So mass of solution is 200 grams equal to mass of solvent plus mass of solute, which is 15 grams of sucrose. So to solve for the mass of solvent, you transfer 15 grams onto the other side and it becomes negative. So 200 grams minus 15.0 grams, this will be the mass of solvent. So the mass of solvent is equal to 185 grams. However, the required unit for solvent is kilograms. So we need to convert 185 grams to kilograms. We are familiar with the conversion that 1 kilogram is equivalent to 1,000 grams. So grams will cancel, and this is equal to 0.185 kilograms. Now we use this formula to solve for molality. So molality is equal to the moles of solute. So that's 0.0438 moles divided by the kilogram of solvent. So that's 0.185 kilograms. And if you solve this in your calculator, this is equal to 0.237 mole per kilogram, or 0.237 molal, small letter m. And this is the answer to question number 3, or example 3. Example 4, what is the molality of a 0.500 kilogram aqueous solution containing 0.111 moles of glucose? So glucose is our solute and our solvent is water, since this is aqueous. In the problem, we are given already the moles of solute, 0.111 moles. However, we are not given the kilograms of solvent. Instead, we are given the kilograms of solution, 0.500 kilogram of solution. So we need to find first the kilogram of solvent. So we will be using this formula. So mass of solution, that is 0.500 kilograms, equal to the mass of solvent. We don't know that yet, so just write mass of solvent plus mass of solute. Take note that in the problem, we are given the moles of glucose. So we need the mass of glucose. So we need to convert 0.111 moles of glucose to kilograms of glucose. So we are given the molar mass. 1 mole of glucose is equivalent to 180.156 grams of glucose. So moles of glucose will cancel. Now you have grams of glucose. Then you convert grams of glucose to kilograms of glucose. And we know that 1 kilogram is equivalent to 1,000 grams. So grams of glucose will cancel, and this becomes kilograms of glucose. And if you solve this, this is equal to 0.02 kilograms of glucose. So this is the mass of our solute. So you put that in the equation plus 0.02 kilograms. To solve for the mass of solvent, you will transfer 0.02 to the other side, and it becomes negative. So 0.500 kilograms minus 0.02 kilograms, this is the mass of the solvent. So the mass of solvent, that is equal to 0.48 kilograms. Now that we have the moles of solute and the kilograms of solvent, we can go back to this formula to solve for molality. So let's just make a little box. Molality is equal to the moles of solute. So that's this one, 0.111 moles. 0.111 moles divided by kilogram of solvent. It's this one, 0.48 kilogram. And this is equal to 0.231 mole per kilogram, or 0.231 molal. This is the final answer to example 4. Our last example is example 5. A 4.97 molal aqueous solution of acetic acid contains 74 grams of acetic acid. What is the mass of the solution? So this is quite a tricky problem, so I will guide you throughout the solution. So acetic acid is our solute and our solvent is water because the solution is aqueous. The first step you need to do is to convert 74 grams of acetic acid to moles of acetic acid. So 74.0 grams of acetic acid. So let's just write AA. We are given the molar mass. So 1 mole of acetic acid is equivalent to 60.052 grams of acetic acid. So grams of acetic acid will cancel, and this is equal to 74 divided by 60.052, that is 1.23 moles of acetic acid. Now that you have the moles of solute, you will then use this formula to solve for the kilograms of solvent. So molality, we are given the molality 4.97 molal. Remember what I told you a while ago? When you say molal, that is also equivalent to mole per kg. So 4.97 molal is just 4.97 mole per kg. That is equal to moles of solute, so 1.23 moles divided by kilogram of solvent. We do not know this yet, so just write kilograms of solvent. So we will solve the kilograms of solvent. So to solve for the kilograms of solvent, the first thing you need to do is to multiply both sides of the equation by kilograms of solvent. So kilograms of solvent will cancel on the right side. So what remains on the right side is 1.23 moles. And on the left side, you have kilograms of solvent times 4.97 mole per kg. Then divide both sides by 4.97 mole per kg. So on the left side, 4.97 mole per kg will cancel out. So what remains on the left side is the kilograms of your solvent. And on the right side, moles will cancel and the remaining unit is kilograms. So 1.23 divided by 4.97, this is equal to 0.247 kilograms. So this is the kilograms of solvent. The problem is asking for the mass of the solution. So we will be using this formula. However, the problem did not indicate what unit we should use, if it's kilograms or grams. So it's up to us. And in this solution, I will use kilograms for the final answer. So mass of solution is equal to the mass of solvent, which we solved earlier. It's 0.247 kilograms, plus the mass of solute. If you read the problem, we are given the mass of solute, which is 74 grams. So to make the units uniform, we will convert 74 grams to kilograms. 74 grams, 1 kilogram is equivalent to 1,000 grams. So grams will cancel, and this is equal to 0.074 kilograms. So the mass of solute is 0.074 kilograms. So the mass of solution is 0.247 plus 0.074. This is equal to 0.321 kilograms. So this is the mass of solution. If you want to convert this to grams, this is equal to 321 grams. So the answer to this question is 0.321 kilograms or 321 grams.